Hello everyone, we're fortunate enough to be joined today by Meng, Wong, and Julian Haight, and they are going to be discussing with us turning email upside down, RSS email and IM2000. And Meng actually is the founder of PObox.com, and Julian is the founder of spamcop.net, so this should be a very interesting and engaging presentation, and I'll turn it over to these gents. Thanks.
So thanks for coming. This is my first time at Google, and it's a real treat to be here. Thank you very much. So this project is really just a hobby project between Julian and me, and it doesn't really have a name. And it's kind of an idea that's been floating around for a long time, and so people have been calling it things like IM2000. I've been calling it RSS email. You could call it Hypertext Mail Transport Protocol. That's what Nathan Cheng calls it. He wrote an article on Circle ID a while ago. Call it HTMP. And we kind of came up with the name Stub Mail after a while, or Stubby Mail. So it's me and Julian. We're going to talk about this. Julian founded SpamCop. How long ago, Julian, was that?
98.
98. All right. So you guys have heard of SpamCop, right? Yes? Good. And I founded PObox.com back in 95. And most recently, I've been working on a project called SPF, which got embraced and extended by Microsoft. So the basic idea here is, all right, let's start with the idea that we've got this one thing, email, SMTP push, and then we could flip it around and say, instead of doing push email, let's try and do pull email. And there's kind of a long tradition of doing pull technologies now. The web, right, is basically pull. They've got all this stuff on the website, and you pull it down. RSS does that too. And the way I see it, spam is basically an unsubscribe problem, right? If you go back about 10 years to the early days of spam, people were always like, stop spamming me, right? Please unsubscribe me from your mailing list. And today we don't really talk about that very much, but the idea is still there, right? And we don't see this problem on the web with blogs, right? You never complain, I'm subscribed to this blog and it keeps sending me stuff I don't want and I can't do anything about it, right? You just unsubscribe. You never say, I keep going to this website and I can't stop. So if you think about email, the way mailing lists work, it's like, I have to send a message to you to say, please stop sending me stuff. And that's completely backwards. It just doesn't make any sense. So I think we should put the power back in the hands of the user and just say, well, you know, I'm going to keep track of who I want to get mail from. Now, this is an idea that's been around about 10 years now. And ever since then, everyone has been saying, no, it's not going to work. It's impossible. But you know, the way Julian and I saw it was, this just gives us an opportunity to do science, right? And science says, let's come up with a hypothesis and disprove it. And so the hypothesis here is, you know, let's just build it and we'll try to make it work between the two of us. And if anybody else wants to come in and join the party, then they're welcome. And if it turns out that it does not in fact work, then that's fine. And so, just scoping the project, the goal is really, really small. This is just a hobby project between Julian and myself and anybody else who wants to join. And the objective is that we should be able to email each other without worrying that the mail got blocked by a spam filter. So maybe I want to send Julian a message that says, hey, check out this email. It's a really clever spam, or it's a really clever fish, or hey, Julian, have you thought about getting some Viagra? Right? I don't want that message to be blocked. And today we have to worry about that. We're not trying to change the world. We're not trying to tell everyone, okay, let's discontinue email. Let's do a big transition strategy. I've tried to do that before with email, and while it has worked to some extent, it is a much bigger job than we can do part-time. So we're not trying to do that. We're not trying to get everybody in the world to stop using email and start using this. So not the goal. If spam couldn't kill email, we can't kill email, right? So let me talk you through, for anybody here who's sort of not that familiar with SMTP, this is how the mail stream works. So you've got the user, sends mail, it typically goes up to their sender ISP, your little MTA, and the sender ISP dumps it over to the receiver ISP over the net, where at some point it gets pulled down by the receiver. Now, if the receiver is not around, suppose they're sitting in a technical presentation, not online, then the message just sort of sits on the receiver ISP until the guy shows up. And if he doesn't show up, then it just sort of piles up and all this spam sits on the server, spinning. until he does show up, and then he's like, oh my God, all this spam just came down my connection. And so the poor end user, he's like, oh, I don't like getting all this spam. I don't like getting all this stuff. It's too much. So what do the end users do? They're like, all right, I'm just not going to bother with email. In fact, I don't care about downloading my spam. In fact, I don't care about this entire SMTP infrastructure anymore. All I want is to just talk to my friends. And so they're like, just IM me, right? And a lot of people are doing this nowadays. If you look at what the young people are doing, the teenagers, they're all using IM, they're all using sort of closed MySpace type systems. Email is not really part of the picture for them. But the problem with IM is that if you're both, if you're not both online at the same time, then you've got this disconnection problem. And so you still need some kind of asynchronous mode where something that's always connected to the net is able to buffer these messages for you. So I'm using this term very loosely. Sender ISP, it's just something that's always online that the messages can sit on even when the sender and the receiver are not there, right? So the simple model here is the sender sends a message, it goes up to the sender ISP, and it gets pulled down directly by the receiver. So it's very simple. Instead of popping your mail from your ISP, why not go pop the mail from their ISP? And 10 years ago, when IM2000 came around, the big paradigm was, all right, email has to be stored and forwarded. We've got all these different hops, and email has to be forwarded from one hop to another. 10 years down the road, everybody's used the idea of just doing RSS, just doing sort of the web. They use the idea of, I'm going to upload stuff to my server, and then if anybody's interested, they will go pull it down. So if the receiver goes away, if the receiver is not pulling down mail, the mail will just end up sitting on the sender's server. And I'd much rather have it piling up on the sender's server than at the receiver's server, right? For a long time, I've been working on anti-spam for the last 3 or 4 years now. A lot of people have been saying in the anti-spam community, we could solve spam if only we could shift the cost to the sender. Right? And there's been a lot of ideas that have been proposed for this. So like e-postage, people are like, let's charge a millicent per message. And all of these schemes sound good until you actually think about how it would roll out, right? Because 1/1000th of a cent isn't that much here, and you're like, all right, well, I could send a couple thousand emails and it would only still be pennies, but you go to Africa, you don't want to charge Africans a lot of money to send mail to the US, right? So Microsoft had this idea, let's make the sender burn lots of CPU, so we slow them down. But the problem is with zombies, right? The zombies have more CPU than anybody else. So I think the solution is actually really simple. I think we can shift the burden to the sender if we just look at it in terms of disk. In the modern paradigm with SMTP, the receiver stores the message. The receiver has to have lots of spinning disk, and it's very expensive for a receiver ISP to store email and spam. Now, what happens is the email gets downloaded, the spam stays on the server, right? And I spent some time at Earthlink, and Earthlink was not happy about this. With the sender storing the message, spam becomes the problem of the sender, which is where it belongs, right? So I think if we want to shift the cost to the sender, looking at who has to maintain the disk is a really good way to do it. So I'm going to talk a little bit about kind of the specifics here. The receiver has to maintain an address book, and in the same way that you maintain a subscription list for your RSS feeds, you maintain an address book for who you want to get mail from. And if there are 3 people in your address book, there are 3 people sending mail to 3 different sender ISPs, you have to pull down mail from each one of them. And you might think that this is kind of a problem because, okay, so he sends me mail, it sits on his server, I don't get the mail till I go out there and I pull it down. It's inefficient, right? And also, what if he sends me mail once and then 6 months go by, right? I don't want to have to keep pulling. But it seems that in the world of blogs and RSS, people are like, well, we don't really see this as a problem, we just do it, right? And even if it's a waste of bandwidth, well, wasting bandwidth makes sort of the graybeard IETF crowd upset, but it doesn't really make anybody else upset because bandwidth is cheap. So, politics. So in the simple case, I said, all right, well, maybe we can address that problem by adding these little stubs, right? These little UDP notifications, so that when I send Julian a message, it actually sits on my server waiting for him to come pick it up. But at the same time, I send this tiny little UDP packet that says, I just sent you mail, come and get it. And what the packet looks like is just a real simple mail from me, mail to you, and here's the URL where you can go download the rest of the message. And everybody sends these little stubs. They end up being stored by the receiver ISP, so there is some disk. But I'd much rather have these little structured stubs, right, in a database than these arbitrarily large messages taking up disk. So it's easier to manage these little DB things. And even if the stubs don't get sent, right, it is still the receiver's responsibility to go out and poll. So even if all these UDP things fail, that's okay. So anyway, the receiver goes to their ISP and says, all right, who has sent me mail? Downloads basically your list of dirty senders, right? It's a dirty list. And then he goes out and polls the original mail. And I think that is enough of an answer to say, if we bring in these little UDP stubs, then the inefficiency of polling becomes not that bad, right? And what does that leave? That leaves the first contact problem. So what happens if these guys over here are not yet in the address book? This is the question that everybody always asks me. So the answer is, that's not really our problem. We can say, let's go back to the idea of like the opposite of every great idea, right? Today, if I give you a business card, what that means is, here's my email address, please mail me. Maybe tomorrow what that means is, here's my email address, let me mail you, right? So you go back and you type it into your address book just like you would, but instead of you being able to mail them, it just means that they can mail you. Maybe we can say, all right, let's use these little UDP stubs to notify that there's this new guy out there and he wants to send me mail. And if they just keep sending you these stubs, at some point I might go download the message. But this means that there's kind of a policy change, right? It means that receivers have to respect stub notifications, and it changes the design a little bit, and it brings back the spam problem. So it's kind of an issue. At that point, I think we can still bring in reputation solutions. We can say, let's figure out what people think about these senders, and if they're a good sender, then we'll read the mail, and if they're not a good sender, then we won't. And that solves sort of the United Airlines problem, right? Like, I sign up with United Airlines, and they send me Mileage Plus notifications. And at no point did I ever go in and put in United Airlines into my address book, but I still want to get these notifications because they're a generally recognized okay group of people. And I think reputation systems can help say, well, these are the Fortune 1000. If they send you mail, it's probably not spam, and so on. So, going back to saying it's not our problem, we'll use some kind of out-of-band mechanism to introduce new senders to the address book. We can say, oh, maybe one of those out-of-band mechanisms is email, right? I mean, email is still there. We can still mail you. Once you're in the address book, the MUA can do all kinds of really smart things to say, all right, now that I've gotten this first message from you, I can subsequently keep polling you. And, I've never heard of this objection to other things like IM. Yes, you got a question?
Sorry to interrupt.
Yes.
I mean, obviously UDP is more lightweight than TCP, but it's also best separate. And if it was TCP, it seems like it would more solve the first contact.
Yeah. The reason I chose UDP was because you got to think about denial of service attacks. You got to think about spammers, right? Spammers are going to try and send you lots of mail. And if we reduced it to the point of if spammers are going to send us unsolicited stuff, I would rather it be UDP than TCP, because there's going to be a lot of people out there writing these implementations if this thing takes off. And it's a lot easier to write a UDP server that is resistant to flooding than to write a TCP server that's resistant to flooding. That's my theory.
You use a huge piece of functionality, which is the first contact that you lose something.
Yeah. So instead of moving this little blue ball, instead of saying it's UDP, maybe we could say it's some kind of HTTP request. So it's TCP. Maybe you could submit some XML thing saying, here's the sender, and instead of being a small UDP thing, it's a big TCP thing. But the semantic is basically the same. Right? So in IM, we've got the idea of, here's my buddy list. If you're not in my buddy list, I'm probably not going to accept messages from you. And I haven't heard anyone complain, well, as an open source author, I get lots of unsolicited IM contacts from outside, and I need to read those. It's just a different set of expectations. Email is what I like to call the medium of least reserve, right? You can always expect to send somebody an email. You can't always expect that they'll read it, but that's the way it is now. Did you have a question? Yeah.
Maybe you're going to answer it later, but anytime you introduce any kind of receiver notification, like you keypad alert the implementation ends up being, you introduce the opportunity for spoofing.
Right.
So you could easily say, here's a message from someone in your address book, go to this URL, which is not that person in your address book. How would you deal with that?
You'd have to tie it really tightly. You'd have to say the address book is the authoritative source of sender outbox URLs. And if somebody sends me a URL that claims to be from this sender but isn't really that sender, I have to discard that. But yeah, let me get into the address book a little bit more. Let's go back to the goal, right? The goal here is for Julian and Meng to be able to email each other. So some of these issues don't really apply to the goal. I think we can get around them. So Julian, maybe you want to talk through a little bit of what we've done, or
yeah, I have some ideas
this is a
about
good
the
time.
contact problem. I mean, I can talk about it.
Could you use the
Why don't you get up to the mic, and we'll take a couple of questions, and
Come join me up on the podium.
take a question. We'll go. Let's talk about like the benefits, the pros, the cons, the architecture, and then we'll get into the implementation. Okay? You have a question?
Yeah, you assume that senders can release resources so that spammers wait for their resources, right? But the spammer can generate the message on the fly. So they don't spend any disk investigation.
Right. So this is a good point. Spammers are actually more agile than regular email sites because they can dynamically generate messages. So if you're getting real email from someone, if you issue like a 400 error code and say come back again, that real sender has to then spool that message on disk. A spammer is basically running all of this out of this huge mail merge template, right? And they've just got a little database that says, well, this guy accepted the mail, this guy didn't, but they've got one message that they're just trying to send a lot. In my model, I'm assuming that, I'm trying to shift the cost of disk to the sender. I'm assuming that even if you're a spammer, you've got to have some disk somewhere that's permanently connected, right? And maintaining that site, even if it's not economically costly, it'll be a way that we can track you down, right? So with zombies, what will zombies do? Zombies will say, all right, instead of getting our own spam server with an IP address, let's send mail through the ISP. And the ISP at that point has a place where they can say, okay, let's do zombie mitigation. If they're sending this virus, if they're sending this spam, we know that this customer is infected and then we can deal with that.
Let me answer the same question.
Yeah.
I reject this whole idea of trying to layer on a first contact solution. You have to be introduced, or somehow you have to out of band get this person's thing. Like instead of you giving me your email address, we give each other our email addresses. Once we send each other email, then we're introduced and we can communicate. The United Airlines example is good too. I would say the way you do that is when you sign up for the Mileage Plus program, you click on a link which brings that address into your address book. And the first contact problem, it's similar to email. You have to have some way to initially do it out of band. Even now, it's like you click on an email address on a website to get to somebody, or how does anybody get there? You kind of layer on things at that point.
I don't see how you can argue that. You're clearly losing functionality. Just like Meng said, I'm an open source author, I get a lot of unsolicited mail. It's a clear loss of functionality. It's easy for notifications, especially if it's easy to solve it, but I don't see how you can just say it's not a problem.
It is a problem. I mean, it's a loss of functionality, but it's an intentional cutting off of a cancer.
The way we broke it down, right, is we said there's stuff that we're trying to solve, and then there's stuff that's not our problem. And we intentionally said that is out of scope. Yeah.
So if you're very successful, everyone in the world does this. Doesn't it mean that every ISP has to support many more connections than they do currently? They just have their own user base doing POP right now. Now they have to support anybody in the world pulling them. And that doesn't seem to be something like AOL or email.
Why don't I go through the implementation that I've actually done for this?
Well, let me, just to address that point,
some of the network issues.
just to address that point, I think I would be much happier in a world without spam, with all the network load that we've imposed, than a world with spam, with all the network load that imposes.
Because that ISP is doing all those SMTP sessions from all the spammers. So it's not just POP.
There's actually not that many spammers. There's a lot of users, and it's a lot of connections.
There are a lot of SMTP connections at an ISP that's being spammed. I mean, there's, you often run into denial of service. Just
Not every home PC is a zombie, but every home PC receives mail. So that's how much you're going to increase the number of connections.
But each zombie is doing exponentially more than a normal person. I mean, a zombie is maintaining thousands of simultaneous connections continually, 24 hours a day. So the load they're imposing on the infrastructure is much higher than a legitimate user who checks one POP server once every 5 minutes. A zombie is doing thousands of connections every minute.
You can also rate limit to each URL, right? If I was an ISP, I could say I don't want people polling for emails stored on my server more than once every 5 minutes.
Sure.
Yeah.
And here, I'll go through this, and it'll help show how we've tried to address some of these issues with the protocol as well. This is a little hard for me to understand. I've lost my present button. Where do you see it?
That's 5. It's a slideshow.
Thank you.
There we are. Okay. So, I've been talking with Meng about this, and at some point I sort of gathered a bunch of the ideas that I thought were practical and feasible, and decided to just run with them and implement a solution. Under my implementation, I really was interested in having security be a major part of it, and so I made it as a shell around GPG, where all the messages are signed and encrypted by default, and the GPG keyring serves as the address book / whitelist. I also wanted it to be easy for somebody to get started with, so my implementation is also an SMTP proxy, so it can be used with any mail reader, and it fetches into a mail queue, again, to provide compatibility with all the existing software. Obviously spam-free, as Meng already talked about. There's no unsolicited contact. And so this is the network model that I ran with. It can change, obviously, but here we have the sender server, which is just an Apache server running a CGI. Again, ease of adoption. That CGI then spawns a daemon, which will listen for polling, and the polling is done in UDP. But I don't have a UDP notification in this implementation. Instead, the recipient continually polls all their senders. So they're blasting out a bunch of UDP packets for everybody in their address book every, 5 minutes. They expect to receive back a packet. If they don't, then they fall back on a heavyweight polling where they actually do an HTTP request that's signed. And that's how they get their mail. These are the 3 parts. The SMTP2 stub is a gateway between SMTP and
pushing the mail via HTTP onto the sender mail server. HTTP to mbox is the recipient side, pull all the people in the whitelist, pull down any mail that exists. Post manager is the CGI that does both sides of the sender server mail store. Basically an outline of the UDP protocol. There's a cookie that is established when the heavyweight polling occurs, which is signed so that you know which recipient and sender you're talking about. Basically how you tie in the encryption. Cookie's hard to guess. If the server sees a request it doesn't understand, it just doesn't respond. If it sees one where there's no one in the address, or there's no associated authentication with the cookie, it responds saying, you're going to have to do a heavyweight poll. Basically talking about the PGP encryption happens on the local machine, so it's end-to-end secure. Man in the middle can maybe cause someone to poll when they don't have to, or see who is sending mail to who, but the messages themselves are encrypted. Talks a little bit about how you can defend this against the denial of service by trying to correlate between the UDP and the TCP. This is one of the things I think about having dealt with a lot of denial of service attacks before. So I tried to avoid some of the things I've seen go wrong with SMTP with this. It should allow people to completely ignore the UDP packets if they want to, and force the client to do a little extra work to do an HTTP signed, do you have mail from me? And this is an alternative to the default installation, which I would envision being on the person's local PC. Instead, you can imagine having this installed on a LAN server, and the people using it aren't even aware that they are using it. This just takes over for your regular SMTP server and your regular POP server by running it in a centralized place, so that, for instance, you could monitor everybody's email or whatever. And then there's all sorts of future ideas about extensions that you could do. First contact things like the stub notifications. If you want it, you can turn that sort of thing on, but then you're back in the world of spam. And right now the implementation assumes that your local machine is secure. In a future implementation, you'd like to see the entire local mail spool and all the mailboxes and all the key ring encrypted. Right, and right now the implementation is limited. It has a few inefficiencies that you can easily see where there would be room to improve. For instance, if you're having Hotmail and Yahoo talking to each other, you want Yahoo to be able to say, do you have mail from any of these people to any of these people, rather than saying, for each of these people, do you have mail from this guy to that guy, from this guy to that guy, etc. So there's various places where you could improve the protocol as is. That's it. Okay. And all that software is written. You can go to stubmail.com, download it, and start to use it. It ties into GPG. If you haven't used GPG before, all you have to do is install it. It'll create a keyring for you. It'll create a key pair for you. So it really tries to make adoption easy. It will, if you want to integrate it into your existing email structure, when you send a message to this system, it'll check to see if the recipient is compliant. If not, it'll fall back on regular email to send the message. Hacks are welcome. If you download it and you want to add any of the stuff or whatever your pet feature is, go for it. It's all open source.
I'm killing the projector here. So, okay. Let me point one thing out, though, which is that a lot of these extensions, like the whole idea of doing UDP, of doing crypto, all of these extensions are peripheral to the core concept, which is that the sender has to store the mail and the receiver pulls it down. You can layer all kinds of enhancements on top of that, but if you don't like them, there's different ways to do them. You have a comment?
I have a question.
Yeah.
I'm a little confused about the economic argument. So currently, the idea is the spammer's paying for bandwidth already, and this will add the cost of storage on top of that. So what are the numbers? How much is the spammer currently paid to spam people, and how much more money will this impose on this spammer? I always thought disk was really cheap, so I'm a little confused.
Disk is really cheap unless you are Earthlink or Gmail, and then you're spending a little bit more money. What we're trying to do is cut the receiver ISP out of the loop. Right? Instead of storing mail out here, which is one centralized point. If you have 1 million users, you have 1 million mailboxes and 1 million, units. If we move the mail from here to here, then it becomes possible when you actually want to download the mail gets downloaded straight to the client, and there's 1 million hard drives out there. Each client has their own. So the economic argument isn't quite so much that, all right, let's try and make it expensive and painful for the spammers, as much as it is, let's just try and make it less painful for the receivers. Right? The spammers are paying a certain amount of money in traditional scenarios, but most of the time they're actually sending mail through zombies. Is that right, Julian? Yeah.
Well, I go back to the disk is cheap thing, is that it actually doesn't cost a lot to store spam messages on the receiver. I don't think it's a big problem. And actually, most users don't care about that. They don't want to go through, they don't care that Earthlink pays money for that, right?
Right.
They just care about spam. But yet
Earthlink cares. Right.
Everyone cares now.
Earthlink cares, but if they had to impose a open way of doing email on users to solve the problem, there are cost problems. Users wouldn't like that.
That's true. That's true too.
It's comparable to the NNTP thing, where all ISPs had an NNTP server, but now it's sort of a value-added, pay us money and we'll give you access to our new server. Maybe 20 years down the road, if everybody is doing this or IM or something like that, an email account is an add-on to an ISP account, where the ISP is really back to just maintaining a network, not all these add-on services. And maybe you save $5 a month. It is one of the big cost centers for ISPs, not so much in the infrastructure itself, but in the people to manage it and take the complaints and try to build the filters and sort of prop the whole thing up.
So users now store all their mail on their home PC.
In this model, it's either on the sender server or their home
You
PC.
can't access anything, you lose your laptop, all your mail's gone.
Well, you can still implement webmail.
No, I would suggest that if you're going to have that kind of synchronization situation where you have multiple endpoints, that each one of those endpoints should maintain a copy of the mailbox, and it could just go out and pull that message down each time, right? It's kind of like
So
IMAP.
when does the sender get to get rid of it?
Only when the receiver says so. There's a separate API for fetch the message and delete the message. And you can do a message list anytime you want.
Now, so
Or
this
if
is
the sender says so, if the sender's like, that's been in the outbound queue for 100 days, I'm going to get rid of it despite the fact that the receiver hasn't removed it.
one of the
The
benefits.
sender can make that choice too.
One of the benefits is that the sender knows when the message has been retrieved. Yeah.
So you've created another tier of email, so now I'll have a set of email which I'm pretty confident is spam free, and I might want to limit the number of people who arrive in that channel. Do you have any provision for putting someone back into the generic send me SMTP email? Like, oh, I arranged for this secure channel with you, but I don't like your email, your mailing list that sends me too much stuff, whatever. Go back into the normal bucket.
That's a good question. I don't think there is. I mean, it's pretty much domain by domain. If the domain supports this protocol, then senders are going to assume that that person will fetch from them.
You just unsubscribe from their feed and
Yeah.
start reading their SMTP emails.
Yeah, just take
But they
their
wouldn't
key
know
out
to
of your
route
key
read
ring.
your SMTP, presumably, right? Presumably they wouldn't be sending you 2 copies.
Right. The sender won't know that you've done this. The mail will just start to go nowhere.
Well, it'll pile up on the receiver SMTP server.
Have you talked to DJB? Do you know what he thinks?
I've not talked to DJB.
I'm afraid of talking to you.
So I think something like this actually has benefit for actually sending out spam rather than preventing spam. But spam in a good way. So if I wanted to send a large file to a whole bunch of people, this is a really good way to do it. And I can see that being a benefit.
If you want to talk about Viagra, this is a good way to do it.
Right. You don't have to actually alter the whole email protocol to do that. You just add something and saying,
Pointless only.
there's a large message sitting on this server over here that supports this protocol. Sure.
But, so you could send a stub, not as a UDP, not as a TCP, but in the form of an email message, right, SMTP. But we were a little bit worried that if we did that, they might not get through.
Right. That's another thing is the reliability. More and more now, people are complaining like, I didn't get your email, or they send an email and they follow up with a phone call. Like, go make sure you got that message from me, and like things
Right.
start falling on the floor more and more.
If you use SMTP and your stuff really does prevent spam, then Spam Assassin would just have a rule that allow that through.
Spam assassin, like, who
Well,
knows?
that may be a way to evolve this rather than have people just like change everything.
Solving the I didn't get your mail problem, if I'm the receiver, I can just sit there and keep banging on my refresh button, right? And I can say with confidence, I'm looking at everything that's in your outbox for me, and you haven't sent me anything. Much more confidence that way. So that's one of the benefits. Yeah, you can send a 2 gig video if you want. You upload the video, and if they pull it down, they pull it down. If they don't, they don't. So each attachment could be a separate file.
That application actually sounds a lot like just upload your video to a web server and mail them the URL.
Right.
Absolutely. IM them the URL.
And you send it. Absolutely. Yeah, we're getting there.
It's pretty much equivalent to that.
I'm not familiar with DJB's original proposal, but I'm curious how your implementation differs from it, if at all, from what he was suggesting.
He has no implementation.
Yeah, I'm not that familiar with it either.
It was just an idea.
But
As far as I know.
from what he was suggesting, did you take that idea and extend it to certain things?
Yeah.
I mean, his core theory was sender stores. I'm not sure exactly how he proposed to implement that. I doubt it was by polling with UDP.
Yeah, if you look at his website basically says, well, here's the basic idea, and there are a whole bunch of questions that this idea leads to. And, for example, how do you do polling? How do you do encryption? How do you do this? How do you do that? And we've answered those questions basically by saying, all right, the core idea is to do HTTP GET, and we're going to have encryption, and everything on top of that idea, how you answer all of these additional peripheral questions, you can answer them in different ways. You can say, all right, fine, let's use PGP for the address book. That's one thing that we're doing. But you don't have to use PGP for the address book. You can use some other kind of address book if you want. You can do all kinds of, you can answer all these questions in different ways. You can say, let's do introduction by going to science fiction cons and doing PGP key signing.
I thought it would be fun to do a cell phone Bluetooth application for key exchange.
But you don't have to do it that way. You can do it any way you like. So I ended up building this huge list of different extensions and enhancements that are completely optional, that different people can implement in different ways. But if none of them are there, you can still get the core functionality. So I don't know if that quite answers the question, but this is sort of approaches the philosophy.
One of the reasons to put the crypto in the core is just to make sure that you are getting the messages from who you think you are. If you do the key exchange in a secure way, then the whole thing is authentic.
Right.
You know who you're talking to.
Yeah, we felt that it was high time to get real PKI into the system. And we didn't want to have to do PKI as a patch. We wanted to be in on the ground floor.
And you don't have to have a password or anything. I mean, it sort of solves a lot of the other authentication problems that just become non-issues once all the messages are encrypted. You know, if I guess the message ID of the message that you have and download it, it's garbage. It's just random crap.
Any other comments, questions?
So you can also just both get Gmail accounts and send each other mail. You would never put it in the spam folder.
Yes, we're seeing this movement back to closed systems, right? This is why MySpace is very popular. If you want to talk to anybody who's 15 years old, you got to get a MySpace account.
And other solutions like this have been tried, but they're all closed. And I think that's one of the reasons they haven't taken off. Because with this one, you can talk to somebody in Africa or a different domain or whatever without being beholden to one provider of technology, one host, etc.
Yeah, the moment you move
Much
from
as we love Gmail.
The moment you move from closed systems to open systems, and the moment you have federation, you will have spam. If it's push. If it's pull, then you have a fighting chance. Yeah.
So you have an implementation. Are anyone using it? Is the user base still 2?
We exchanged email for the first time last night. So we had a little bit of a background, right? So this is the goal. Remember, we can email each other. And it's done because we're starting in April. We had a little hackathon. We got together and we said, all right, guys, you guys have been like talking about this. Some guy actually wrote a PhD thesis on the idea of pull email. And I don't know if he actually implemented it. He just wrote a thesis on it. And so we said, let's do it. We did it. We built it. And yesterday, we had the first interoperable exchange of email. Thank you for providing a forcing function. But it works.
Yeah, and we would love to expand the circle though. The software is on the website. You can download it, and once we get your key, we can exchange some email.
Hey, it's kind of like how Gmail is invite only, right? You got to have the connection to the system.
Right. You'll have to email us your address. Well, one simplification on this that's not entirely secure is the key exchange happens automatically with just a simple email address. So he gives me his email address, I give him my email address, and as soon as I send mail to him, StubMail automatically asks his domain server, where's your key server, asks the key server what's his key, brings it into the local key ring, and then encrypts mail to him and so on.
Well, that's one implementation.
That's the current.
That's the current implementation. There are lots of ways to do this. Here's an alternative, right? Here's my PGP keyring. Here's my key. And you'll notice in the comment field in this little UID here, I've got a URL, right? So I've got my name, I've got my email address, and I've got my Outbox URL. And you can go retrieve your mail from that Outbox URL.
Without talking to the domain server.
Without talking to the domain
server. Right. And that's one of the things we're going to implement, RSM. Real soon.
Right. So if you want to change your ISP, all you have to do is go edit your keyring, dump it out, and then suddenly people are looking for your mail somewhere else, securely, without any issue about spoofing. Thank you.